What is time series? It is a forecasting method. It is used to analyze the past year's revenue performance, price trends, and so on. It is an ordered sequence of numerical values. It is measured over equally spaced time intervals. This is very much important. There should not be any gap in the data. For example, you want to forecast next week the sales performance, or you want to forecast the next week stock price. You need to use the last week the data here. So in that case, last week, 5 days or 5 days, right? 5 days data, you need to have it in sequence. In the case of revenue, last 7 days data, you need to have it in sequence. There should not be any gap in between. Here, the goal is to identify the internal structure, the forecast the near future events. This is very important. There is a difference between prediction and forecasting. When it comes to forecast, we are going to forecast the near future events. See, nobody is going to forecast, after 2 weeks or 2 months, what is the forecasted price, stock price, right? So we are interested in the next week forecast. So this week, see, next week, if I buy these stocks now for Infosys and Wipro, what is going to be the future cost? Let's say if you are doing intraday trading or something, right? So in that case, you are very particular about forecasting the near future. But when it comes to prediction, it is going to be longer duration. But forecast the near future only do we do it. Okay, here the prediction is made by analyzing the underlying patterns in the time series data. For example, predicting the future sales of the company by analyzing its past performance. The important thing is the difference is the future events. We are going to predict the near future events using this one. So in the case of time series, the sequential data should be in successive order. Okay, successive order. There should not be any gap here. Okay, so what is YT and YT minus and YT minus 2 and YT minus 3? What does it says? Lag 1. This is today's price and yesterday price, day before yesterday and prior to day before yesterday. Lag 1, lag 2, lag 3. This is lag 1, lag 2, lag 3. And the population of the country listed year-wise, temperature in the city listed by the hour of each quarter. You want to see, right? What is the forecasted price for this one? You can find out. Now the question is, why should I use time series? Why not? Why not? We can use the predictive algorithms like linear regression or something else, right? Here, the independent variables are causal. It is unknown to us and not available. It might not fit the data well and difficult to forecast. So, what do you mean by causal independent variables? For example, I want to predict the stock price of Wipro or Infosys. I want to forecast this one. Okay. And let's say I want to forecast next week what is the stock price for the Wipro, right? And similarly, if you want to forecast the stock price for the Infosys for the next week, so I need to consider. So in this case, I need to know how many number of. So or you tell me what factors can drive the stock price. What factors can drive the stock price? Independent variables. So now the question is, why should I use time series? Why can't I use linear regression or other algorithm? Why time series? When it comes to info, you take any stock price, right? What drives the sales the revenue, right? Revenue of the company, profit and loss, revenue. These are the factors which can drive the company performance. Okay, and quarterly result, all the things. Fine, but we have something called macroeconomic factors like inflation rate, and GDP, right? These values are not because the when it comes to time series, we are forecasting near future, right? In that case, what will happen is the inflation rate and GDP also have an impact on your stock price, but you cannot get the inflation rate and GDP on a daily basis. Every biannual or yearly value, you can get the inflation rate and GDP. In that case, if you take inflation rate and GDP also, in addition to the quarterly results, all the things, quarterly results also, we are getting quarter every once in quarter. But in the case of short term forecasting, right? If you take into account, but this is not the daily thing. In that case of situations, we will use the stock price itself. See here, the stock price is the dependent variable. What is the independent variable? We don't have any independent variable, because the independent variables we cannot consider inflation at GDP because it is not on a daily basis. So when it comes to time series, we use the independent variable itself as a dependent variable itself as an independent variable. What do you mean by the dependent variable itself? We are going to use it as an independent variable. So here you have the stock price, today's stock price. Today is let's 2nd October. 2nd October, what is the stock price of Infosys? Let's say you have something like 4,023. And what is 1st October, yesterday? 4,003. And let's 30 September 4010, something like that. So this is yesterday stock price, lag lag 1, I say lag 2, right? So I call this as YT, as on today, time T. On time T, what is the stock price? And T minus 1, what is the stock price? T minus 2, what is the stock price? That is what we can get it here. The T minus 1, T minus 2 is called lag 1, lag 2, previous day and prior to previous day. Okay, so that is what. So in this case, what we are doing is to forecast tomorrow's sales performance or the stock price. We take yesterday price, day before yesterday price. Similarly, YT minus 3, YT minus 4. We use the existing values that are part of your stock price column itself, right? Existing value itself, we are going to use it as an independent variable to forecast your next week price. So you consider last 1 week stock price. With that, you are going to forecast the stock price for the Infosys of the next week. So in that case, the last 7 days values are already available here, right? So with that, we are going to do the forecasting. In this case, we are not using any independent variable. So I'm talking about univariate time series analysis. You have multivariate time series analysis also there, and univariate time. I'm talking about univariate. In this case, it takes the existing value itself as the lag 1, lag 2 itself has been considered as a this one considered as a independent variable. Okay, so in that kind of situation, right? So here we don't have to have the now you understood why we are using time series. So in the case of time series, in this scenario, we don't have any independent variable. You don't have any independent variables are available. It is unknown to us, not available, might not fit the data well, because if you use the macro economic factors like GDP, inflation rate, it is not, it is not changing on a daily basis, or we are not getting the value on a daily basis, right? With this independent variable, it's difficult to forecast. Hence, what we do is with the existing dependent variable itself, what are the values are there, right? Lag 1, lag 2, we use it as a independent variable to make a prediction. Okay, what are the components are there in time series? There are 4 components are available. One is trends, and this trend shows us a common tendency of the data. It may move upward, or it can go high, or it can go down. That is what trend, right? The trend can be either linear or non-linear. The seasonal, you know very well. The sales of ACs are going up during the summer. The sweaters and umbrellas sales are skyrocketing during the winter season or rainy season, right? Umbrellas are, say umbrellas are more number of umbrellas are sold during the rainy season. The sweater and other things, right? That is sold only during the winter season, and importantly, festival. Right? For example, the sales of cake will peak every December in the US because of Christmas. And in India, Diwali, the Hindu festival, the Diwali is very, popular, and that time the sales is very high. So the seasonal component is nothing but the repetitive patterns at certain times of year called seasonality. Every year, if you compare last 3 years or 2 years or 4 years, you can see that in the October month, and the December month, you can see a peak. See, this is a repetitive pattern, the seasonal variation. And we have some cyclic variation. So this is kind of a fluctuations, right? The cyclic is something like fluctuation. It is due to some recession or some depression. That kind of situation, the cyclic pattern or component, we can see that there is sudden recession happen, job loss. Due to job loss, the sales is not good, the performance, business is not doing good. And the next one is irregular. It is also called as a random movements. This is another kind of movement. This is, this kind of thing, right, are unforeseen, sometimes unpredictable. For example, uncontrollable in nature, and that kind of situation, irregular movements can happen. For example, earthquake or floods or the shutdown, right? These are the examples of random time series components. The COVID shutdown, due to COVID, some shutdown happened. These are all some irregular movements or some random. Okay, randomly it can happen. These kind of things. In simple terms, the trend is nothing but the upward or downward movement in the average or mean value of this thing. And cycle is also upward downward movement, the average or mean value of the. There is something wrong here. Okay. The seasonal, it is a special case of a cycle component, right? So weekly, monthly. The ice creams, right, are sold in summer. The wooden clothes are sold in winter, and irregular, right? So it's the upward or downward movement in the average or mean value of the forecast variable over time. Right? If you see these three things, right, somewhat same. The seasonal is, we know very well the seasonal, what exactly season is all about. There are different types of algorithms are available as part of time series. The Arima, auto regressive integrated moving average, and Sarima, and VAR, vector auto regression. This is the one used it for multivariate time series analysis. And finally, you have something else called exponential smoothing models and profit model. So we will take a look at the univariate time series. Okay, what are the prerequisites to create a Arima model? The mean of the series should not be a function of time. The variance of the series should not be a function of time. This property is known as homoscedasticity. If you see here, the mean and variance are constant, right? Whereas here, if you see non-stationary, the mean, see here, if you take this data set, if you take the mean, this mean is different from this mean. Hence, mean is not constant. Obviously, the variance will not be constant in this case, right? So, in order to fit auto Arima model, the data set should be stationary. So before we build a model, we must ensure that the time series is stationary. And there are two primary ways you can find out whether given time series is stationary. So how do I find out? The one is we can use the rolling rolling statistics and augmented Dickey-Fuller test. Using these two technique, or visually also we can find out, like I shown here, right? Here visually also, when you plot the data, you can find here, but we don't see any, it's a constant. If you take the mean here, if you take the mean, it's more or less somewhat same. It's not exactly same, but somewhat it is closer. But whereas if you take the mean here and here, it is literally different. There are huge differences there. So this is the equation for the Arima model. So this is your constant value phi 1 and y2, lag 1, lag 2. Yesterday's something like yesterday's stock price, day before yesterday price. Likewise, how many lags are required? Plus, this is a constant value, error term. What is the error? So, what is the actual value and predicted value? What is the yesterday's error? Like, what is the predicted value, forecasted value, and what is the actual value? The difference was error, right? What is the yesterday's error? So the combination of these two, right? Here we have the auto-regressive moving average, right? So we have ARIMA stands for auto-regression and moving average. The I stands for the independent, right? The combination of AR and moving, the auto-regressive, Y is a linear combination, last P values, and moving average is constant value plus the effects of dampened white noise, right? White noise, this is the error, right? The combination of AR and ME is called your ARIMA model. So now to find out the given data to find out whether the given data is stationary or not, we use two techniques. Either you can use a rolling statistics. That means, in this case, we are going to plot the rolling mean and a rolling standard deviation. Okay, we plot these two things. So so in this case, if the time series is stationary, right, this one will remain constant with time. With the naked eye itself, we can find out. The next one is the statistical test, right? The p-value is less than alpha. We are going to reject an alpha, null hypothesis. We are going to say, yes, it is stationary. Okay, if you are able to reject it, then it is stationary. And what exactly is rolling average, rolling statistics, rolling average, rolling mean, and all? What does it says? For example, you have something like day 1, day 2, day 3, day 4, and day 5. Okay, if I say rolling average for 2 days, what will happen is, here day one is, let's say, you have how much sales you made. Let's say, 15, 20, 25, and 30, or 10, something like that. This is the sales you made day one, day two. Rolling or 2 day rolling average. 2 day rolling average. If I say 2 day rolling average, what will happen is, in this case, it takes the average, right, after 2 days. Okay, here something like 45, 50, 60 divided by 30 is 20. Okay, the average of day one, average of day one through um, through 2 days. We can say 2 days, right? Through 2 days. And then next time, what will happen is, in this case, right, the rolling 2 day, what will happen is it will ignore the earlier one, and then it take the average of these two, and then it will put it here. 20 to 20, 20, 45 divided by 2, how much you'll get? Almost 22.5, right? So, sorry, 45, 22.5, right? And then it ignores this one, 25, 30, how much? 35. So usually we take 10 days, 10 days rolling average period, or 20 days average. This is what average rolling period. So average rolling mean, rolling average mean. Okay. When you plot the rolling statistics, or when you conduct this test, using which we can find out whether the given data is already in stationary or not. Only if the given data is stationary, you can fit the Arima model. What measures that we use it, what metrics that we use it to evaluate the model performance? We have something called mean square error, and then root mean square error, and MAPE, like linear regression, whatever we use it, right? The same thing we use it here. And for example, once you fit the model, you get an output something like this. Okay, and you'll get something. The dependent variable is prices, and it's an Arima model. And here, this is AR. The one is saying AR, and zero is your moving average. The one is differencing. How many number of times you took the difference? Okay, that is what it tells us. And how many number of records are there? And you can see the log likelihood here. Mm, and here we can see the log likelihood, and we can see the AIC, BIC. Like we discussed about the output of your logistic regression, right? The same thing. On linear regression also, you can get AIC, archaic information, Bayesian information criteria. So in this case, the AIC tells us lesser the AIC, better the model. Okay. And so now the question is, we discussed about lag 1, lag 2, lag 3. You remember? This is the one, right? So to forecast the next week's sales, or tomorrow's sales, or day after tomorrow's sales, right? You need today's sales and lag one, right? So let's say I wanted to forecast for the next 3 days or next 4 days, how many lags that needs to be used, right? That is what it tells us here. Using AAC, we can find out. See, the question is, to forecast the next 5 days or 10 days, how many lags that I should use it? Okay, how many lakhs that I issue is it? In that case, you fit with 2 lakhs or 3 lakhs. take yesterday and day before yesterday, prior to day before yesterday, 3 days, past 3 days stock price, and then you do forecasting, fit the model and see what the AAC value, and take the last 2 days and fit the model and see the AAC. Whichever model's AAC is less, that model is better. So based on which you can determine how many number of lakhs that needs to be used. AAC is helpful in that case. And then the here, right? So the same thing here. So I just splitted it, this part separately. So we can see the error term in sigma. This is nothing but the error term. Sigma 2 is an error term. Our lag variables is L1. Okay. In our example, the L1 is statistically significant p-value, as the p-values are below. So alpha is less than. So hence, if you include this in your model, it makes sense. Try with more than one and see what is the AAC value. And we have something like auto Arima. It gives us the optimal value for the PDQ. See, in the Arima, I'm talking about this one, right? Arima 1 comma 1 comma 0. What is this? Is the one is P, and this is the one is Q, and this is your D. Differencing. So what do you mean by differencing? Supposing your given data is not stationary, you need to take the differencing. When you take the differencing, one time you take the difference, and then use the the auto regressive as P, which means lag 1. Only one lag you take it, and Q is moving average is 0. You take this one. Okay, with this you fit the model and tell me what is the AAC, BIC, and HQIC, everything. And importantly, we need to check whether the lags are really helpful in terms of determining the model accurate performance. Okay, and next one is the L-Jung box and probability. Is the LBQ static at lag 1 is the probability 0, and the p-value is 0.93. This is pronounced as Young and sometimes called a modified box-based test. This test that the errors are white noise. Okay, so this one is the p-value is 0.93. Okay, and since the probability is about 0.5, we can't reject that the errors are white noise. What is the null hypothesis? The errors are white noise, right? So that means error is there, and since we are not able to reject it, there are some error is there. Okay, now we want to make the model meets the assumption that residual is independent. Like a linear regression model makes assumptions, similarly, Arima model also makes some assumptions. The error residuals are independent. Okay, that if it is independent, it is called as a white noise. Okay, the residuals are independent. It should be independent. If it is white, so hence we are not able to reject the null hypothesis. We can say white noise. That means the residuals are independent. The next one is the fit analysis, AAC, BAC, right? AAC, archaic information helps us to determine the scent of the linear experiment. The AAC penalizes the model for adding parameters. When you keep add lag 1, lag 2, lag 3, lag 4, it penalizes that. Okay, and log likely to function like I shown you, right? Identify the distribution that fits best with the sample data. While it's useful, AAC and BAC punish the model, which helps make our model parsimonious. What do you mean by parsimonious? Parsimonious is, we have optimal number of features are there in my model. It should not be like, so many features are there or less number of features are, right? If you have so many features are there in your model than required, then it can lead to overfitting. If you have less number of features in your model than required, that can lead to underfitting. If you have optimal number of features, then your model will be parsimonious. This is a common term, parsimonious. This is one of the best practice, right? So as a data scientist, we need to make sure that whatever the model we create, it should be parsimonious. We should not have excessive features. We should not have lesser number of features. But the Bayesian also, AAC, it also punishes the model for complexity. It is more or less same. So that's it, guys. Okay. Now it is time for us to go and take a look at the time series model. It is already late. I could see most of you dropped out. Even I have some other call is there now. The next week, it will not take more than 5 minutes to give a demo around time series. Meanwhile, you watch my video so that you can come back with some questions.